I am Larry Hatcher. This is Psych 302, Computer Applications in Data Analysis. This is part two of my two-part lecture on chapter 090, ANOVA with one between subjects factor. You'll remember in the previous lecture, I talked about analysis of variance with one between subjects factor, or what it is in general. I went over the basics of computing descriptive statistics and performing the analysis itself, requesting the analysis of variance itself. That was part one. We are now at part two. Part two, we're going to go to pages 34 through 50 of this set of lecture notes. I'm going to lecture on those, and we're going to see how we interpret the results produced by Jamovi, how we make sense of them, and how we summarize those results in APA style. So let's scroll down to page 34, which is where this lecture picks up. To refresh your memory, at the end of part one, we were at page 33 of this set of lecture notes. And I have the red box that says Hatcher stops lecturing for the class meeting covering input assumptions and analysis. Students began working on Jamovi Exercise 09001, ANOVA with one between subject factor, input assumptions, and analysis. That was the previous unit. In this unit, we're going to begin on page 34. And page 34 is where the section headed Interpreting Results from the Analysis begins. Let's scroll down to page 34. And before we actually start reading the text, let's refresh our memory on the study itself. In this investigation, you're trying to find ways that will motivate people to engage in more minutes of aerobic exercise each week. You conducted an experiment in which the independent variable was financial incentives. You had a pool of just 21 college students, and you randomly assigned them to treatment conditions. Randomly assigned 1/3 of them, 7 students, to the low incentive condition. These people were paid a small amount of money for engaging in aerobic exercise. You randomly assigned a different group of 7 students to the medium incentive condition. They were paid a medium incentive for engaging in exercise. And you randomly assigned the last 7 students to the high incentive condition. They were paid a larger amount of money for engaging in aerobic exercise. You measured how much aerobic exercise they engaged in each week over the course of a semester. And at the end of the semester, you determined the average minutes of exercise that they displayed in a typical week. It looks like, these are our results, it looks like the students in the high incentive condition did in fact engage in more minutes of exercise than the other 2 conditions. Looks like the medium incentive condition scored a little bit higher on minutes compared to the low incentive condition. That was the general trend of the results. That's a good place for us to begin. So I begin going over this part of the lecture notes here, halfway down page 34. General trend of the results. Our research hypothesis presented earlier predicted that participants in the high incentive condition would engage in more exercise minutes per week than those in the medium incentive condition. And those in the medium incentive condition would engage in more exercise minutes than those in the low incentive condition. Those means are illustrated graphically in the error bar plot that we requested. That error bar plot is presented below, and the error bar plot is what I've been talking about for the last couple of minutes. The same means were also presented in a table headed estimated marginal means. We had requested those in our analysis, and on page 35, at the top 35, we have this table. Estimated marginal means, it illustrates in table form the same numbers that I showed in that graph a second ago. We scroll down a little bit on page 35. At this point, we don't know whether any of these differences are statistically significant, but at least the general trend is consistent with our research hypothesis. We're off to a good start. We come to this section, omnibus significance test and index of effect size. In the current context, the word omnibus means overall. So an omnibus statistical null hypothesis in a one-way ANOVA is a prediction that the independent variable will have no overall effect on the dependent variable. We therefore state our omnibus statistical null hypothesis for this investigation in this way. Mu sub low is equal to mu sub medium is equal to mu sub high. In other words, in the population, there's no difference between participants in the low incentive condition, medium incentive condition, or high incentive condition with respect to their mean scores on exercise minutes per week. Now remember what a null hypothesis is. It's the hypothesis that the researcher usually hopes to reject. So we hope that our results will allow us to reject the idea that there's no difference between any of these conditions. If we can reject that, it means there must be some kind of difference, and hopefully it'll be along the lines of what we had predicted. Page 36, figure 530.21 provides the ANOVA summary table for the current analysis. I've added call-out numbers like 1, 2, 3, 4 to identify specific sections of this ANOVA summary table. What do I have to say? To the right of the heading ANOVA, we find the name of the dependent variable, which in this case is minutes. And yes, to the right of the heading ANOVA, our dependent variable is minutes. The first row in the body of the table begins with the name of the categorical predictor variable, which in this case is incentives. That's at call it number 2 right here. Yes, our independent variable is incentives. The value below the heading F is the obtained F statistic, which in this analysis is 4.05. The obtained F statistic is the value used to test the omnibus statistical null hypothesis provided above. So under the heading F, we see our obtained F statistic is 4.05. Now, if the independent variable had no effect at all, theoretically, we would expect this F statistic to be equal to 1.0. 4.05 is bigger than 1.0, but is it big enough for us to reject the null hypothesis? To make that decision, we have to look at its companion statistic, the p-value. The value below the heading P is the obtained probability value, the p-value associated with this F statistic. The obtained probability value in this case is the p-value is 0.035. Now hang on, is that true? Below the heading P, yes, the p-value is 0.035. Is that good? Is that bad? The obtained p-value is 0.035. Let's assume that we had set alpha at 0.05 for this analysis. Because our obtained probability value of 0.035 is smaller than alpha 0.05, we can reject the omnibus statistical null hypothesis. We may conclude we have a statistically significant omnibus treatment effect. Now that is good news. The fact that our p-value is less than 0.05 means we have an omnibus, statistically significant omnibus effect. It means there must be some kind of difference between at least 2 of the means. We don't know which 2 specific means, but at least we have our omnibus significant effect that we wanted. Continue to page 37. Significance test is worth looking at, but also worth looking at is the index of effect size. And here at the top of page 37, we have this. The value below the heading omega squared, this is the Greek letter omega with a squared symbol above it. The value below the heading is omega squared. It's an omnibus index of effect size. In this case, our omnibus index of effect size was 0.23. Now, if the independent variable had no effect at all, we would expect this omega squared statistic to be 0. 0.23 is bigger than 0, but is it big enough for us to call it substantial? In this paragraph, I talk about interpreting omega squared, and I end by saying this omega squared value of 0.23 represents a large effect according to Cohen's benchmarks. So it's good news. Our results are not only statistically significant, but we have what would be interpreted as a large omnibus index of effect size. Everything looks good so far. Let's continue. I'm still on page 37, toward the bottom of page 37. we come to post-hoc tests. Post-hoc tests, also known as focus comparison significance test. Post-hoc tests, also called a posteriori tests, typically allow a researcher to perform a significance test for every possible combination of treatment condition means. And they do this while preventing the overall probability of making a type 1 error from becoming inflated. Continuing on page 38, what exactly do they test? They test the focused comparison null hypothesis. Since current investigation includes 3 treatment conditions, the Tukey HSD procedure will perform 3 separate significance tests, one for each possible pairing of the 3 conditions. One will determine whether there is a statistically significant difference between the low incentive condition versus the medium incentive condition. Here is the null hypothesis to be tested. Mu sub low is equal to mu sub medium. In the population, mean exercise minute score for the low incentive condition is equal to the mean for the medium incentive condition. An equivalent way of stating the same null hypothesis is to predict that the difference between the 2 means will be equal to 0. This approach is illustrated here. Mu sub low minus mu sub medium equals 0. In the population, the difference between mean exercise minute score for the low incentive condition versus the medium incentive condition is equal to 0. That is the format that we'll actually use for the remainder of this chapter. Since we must perform a separate significance test for each possible combination of the 3 conditions, the Tukey HSD procedure will eventually test all 3 of the following null hypotheses. And below that, I simply have the null hypothesis for every possible pairing of our 3 treatment conditions. We continue, we're on page 39 now. We have a figure, we have a table. Let's continue to page 40. I'm at the top of page 40. We had requested this procedure when we checked the box headed Tukey in the post-hoc test panel of the Jamovi ANOVA procedure. Results of this analysis appear in the table headed post-hoc comparisons incentives, which is reproduced below. All right, these are the results of our post-hoc test, post-hoc comparisons incentives. Once again, I've added some call-out numbers so it's easier to identify the section of the table to which I refer. The Jamovi post-hoc comparison table. The first section of the table is headed comparison, and the labels below this heading identify the 2 conditions being compared for a given test. Okay, this is below the call-out number 1, and we see the heading comparison. So this first row will compare the low incentive condition to the medium incentive condition. Everything in this row pertains to that comparison. Next row compares the low incentive condition to the high incentive condition. Everything in this row refers to that comparison. And the last row compares medium incentive condition to the high incentive condition. Everything in that row pertains to that. We're going to begin with the first row, the row that's headed with my call-out number 2. The first row in the body of the table is headed low minus medium. This indicates that this row provides information about the difference between the medium incentive condition versus the low incentive condition. What do you mean by that? Well, if you take the mean score for the low incentive condition and subtract from it the mean score for the medium incentive condition, you get a mean difference of negative 3.14 minutes, and everything in this row pertains to that comparison, to that difference. Okay, we come to the column headed mean difference with my call-out number 3. The column headed mean difference provides the difference score obtained when the mean for one condition is subtracted from the mean for the other condition. First value in this column is negative 3.14. This indicates that the difference obtained when the mean for the medium incentive condition was subtracted for the mean for the low incentive condition was negative 3.14 minutes, as we computed earlier. In other words, it indicates that the low incentive participants engaged in an average of 3.14 fewer minutes of exercise than the medium incentive participants. That was call out number 3. Call out number 4, we move over to this part of the table below my call out number 4. In the column headed P Tukey, which is call out number 4, the column headed P Tukey provides obtained probability values, p-values, for the Tukey HSD test. If this p-value is smaller than the alpha criterion that had been selected before analyzing data, it indicates the Tukey HSD test is statistically significant. Let's assume we had set alpha at 0.05 for all our analyses. Table shows that the p-value for the difference between the low incentive condition versus the medium incentive condition is 0.907. Hang on, is that what it really says? P Tukey, I'm looking at the first row. The p-value for the Tukey test for this first comparison is 0.907. Okay. Table shows p-value for the difference between the low incentive versus medium incentive condition is 0.907. This obtained p-value is larger than our alpha criterion of 0.05, so we must fail to reject the null hypothesis. Instead, we must conclude that the difference between the low incentive condition and the medium incentive condition is not statistically significant. Well, that's usually bad news for the researcher. For this first comparison, low incentive condition versus medium incentive condition, this p-value tells us that the difference between those two means is not statistically significant. Let's hope something else is statistically significant. Let's scroll on down. In short, this column headed mean difference and the column headed P Tukey constitute the real heart of the table. This is going to be the thing that you, the researcher, are most interested in. Combined, they tell us the following. Low incentive students engaged in 3.14 fewer minutes of exercise than the medium incentive students, a difference that was not statistically significant. The low incentive students engaged in 19.71 fewer minutes of exercise than the high incentive condition students, a difference that was statistically significant. P is equal to 0.041. Now hang on, what is he talking about here? It's the second comparison. When you take the mean for the low incentive students, subtract from it the mean for the high incentive students, you get a mean difference of 19.71 minutes. Is it statistically significant? It is. The p-value is less than 0.05. The p-value is 0.041. It's less than 0.05, so this comparison is significant, but we're going to see the last one is not. Medium versus high is negative 16 minutes. This p-value is 0.09. That's bigger than 0.05. That's got to be bad news, right? Is that what he says with the last bullet point? Medium incentive students engaged in 16.57 fewer minutes of exercise than the high incentive students, a difference that was not statistically significant, 0.093. Okay, so we found out of our 3 comparisons, one of them was statistically significant according to the Tukey test. But that is just a significance test. What about effect size? Does effect size apply to the comparisons between 2 specific means? It certainly does. On page 41 at the top, we come to focused comparison, indices of effect size. Current section will cover focused comparison, index of effect size. Statistics reflect magnitude of the difference between just 2 specific means. Cohen's D is the prototypical example of such an index, so it will be featured here. I then give you the generic formula for Cohen's D. I say some things about interpreting it. This is Cohen's criteria for interpreting his D statistic. We look at the same table. I'm at the top of page 42. This is exactly the same table presenting post-hoc comparisons that I showed you before, but now we're going to look at a different section of that table. A separate D statistic is computed for each of the 3 comparisons in the current analysis. They will appear in this section. We're going to see Cohen's D statistic is below my call-out number 5. First up, let's make sure we know what we're looking at. The first row in the table, the one with call-out number 2, the first row in the body of the table is headed low minus medium. Earlier, we saw that this row provides information about the difference between the medium incentive condition versus the low incentive condition. If you take the mean for the low people, subtract from it the mean for the medium people, everything in this row pertains to that difference. The column headed mean difference 3 represents a difference score obtained when the mean for one condition is subtracted from the mean for another. First value in this column is negative 3.14, indicating that the low incentive participants engaged in an average of 3.14 fewer minutes of exercise than the medium incentive participants. This value of 3.14 is a non-standardized index of effect size, also called an original units index of effect size, or a raw score index of effect size. Now this is under the column, my call out number 3. And this is a statistic that we looked at a few minutes ago. It is an original units index of effect size, meaning we haven't changed it at all. It's still in its original units. What was its original units? Minutes. So when we compare the low condition to the medium incentive condition, the difference between those two conditions consisted of 3.14 minutes. That's the original units index of effect size. But that's not what we're particularly interested in. We are interested in a standardized index of effect size like Cohen's d, and the next bullet point gets to that. The column headed Cohen's d, under the call out number 5, provides Cohen's d statistic for the difference between the two means. The first value in this column is negative 0.23. Yes, it is negative 0.23, indicating that the low incentive participants scored 0.23 standard deviations lower than the medium incentive participants on the dependent variable. This statistic is a standardized index of effect size because it represents the difference in standard deviations, a yardstick that has the same meaning regardless of the specific variables being investigated. If aliens from another planet were looking at the results from this study, they would know how to interpret this original units mean difference because they don't use minutes. Is 3.14 minutes a big difference, a small difference? I don't understand. But even aliens from another planet understand Cohen's d statistic because it represents the size of the difference in standard deviations. Everybody understands standard deviations. Apparently, one group scored 0.23 standard deviations lower than the other group. That's what Cohen's d statistic shows. Jamovi not only gives us Cohen's d statistic, it even gives us the confidence interval for it. The section headed 95% confidence interval below my call out number 6. There it is, 95% confidence interval. It provides the 95% confidence interval for Cohen's d statistic. Preceding table shows that 95% confidence interval for the current comparison extends from a lower limit of 1.35 to an upper limit of 0.90. Is that true? It is true. For this comparison, Cohen's d statistic was negative 0.23, and the 95% confidence interval extends from negative 1.35 to positive 0.90. So those are plausible values. We never know for sure what the actual d statistic is in the population, but given this confidence interval, it's plausible that the d statistic in the population is probably somewhere between negative 1.35 and positive 0.90. I continue to page 43. Top of page 43. We have now gone over all the results, but we're not done. We still need to write this up in correct style according to the publication manual of the American Psychological Association. So that's what we cover in this section, top of page 43. Summarizing results in APA style. This section shows how we might report the results from the current investigation. In the lecture notes, I give you the complete results section, everything put together. We're not going to focus on that. We're instead going to focus on specific sections of it. On page 44, toward the bottom, page 44, let's take a look at the place where I reported means and other descriptive statistics. In the excerpt from the research article, I said, descriptive statistics showed that participants in the low incentive condition engaged in an average of 29.14 exercise minutes per week The standard deviation was 12.51. Sample size was 7. For the medium incentive condition, the mean was 32.29. Standard deviation 1502. Sample size was 7. And for the high incentive condition, it was 48.86. Standard deviation 14.11. The N was 7. Wait a minute, where did this come from? Means and standard deviations and such. You computed those last week, and I reprint the output here on page 45. Here is the output that provides us with these descriptive statistics we want. When we did the analysis last week, one of the things we requested was descriptive statistics, and this is the table of descriptive statistics. I've circled, I've put rectangles, or I guess it's more like oblongs around the relevant statistics we care about, and I've highlighted the important parts. Number of participants in each condition, in other words, N. Okay, to the right of the heading N, that means number of people in each subgroup. We see there were 7 people in the low incentive condition, 7 people in the medium incentive condition, 7 people in the high incentive condition. That's where my sample size came from in the excerpt. Probably the most important part of the excerpt was the mean, and that appears to the right of the heading mean. Treatment condition means the APA statistical symbol is an uppercase M in italics. Mean score displayed by the low incentive people was 29.14, medium incentive people was 32.29, and so forth. Those are the means that are in my excerpt. What about standard deviations? They appear in the section headed standard deviation. Treatment condition standard deviations for the low incentive group was 12.51, medium incentive group is 15.02, and so forth. That's where means, standard deviations, and sample sizes came from. We continue making sense of the write-up of these results. Toward the bottom, page 45, we have the section Omnibus Null Hypothesis Significance Test. This is how I wrote it up. With alpha set of 0.05, the ANOVA revealed a significant treatment effect for financial incentives. F with 2 and 18 degrees freedom is 4.05. MSE, mean square error, is equal to 193.73. P is equal to 0.035. Wait a minute, where did all this come from? What are these numbers within parentheses? You will recall that the omnibus null hypothesis for a one-way ANOVA states that in the population, there's no differences between the means of any of the treatment conditions. This null hypothesis was tested by computing an F statistic and its corresponding probability value. Those statistics appear at the end of the first sentence in the preceding paragraph. These statistics are diagrammed below. One of the things that I do at various points in my lecture notes is diagram statistics. If we're in some part of a research manuscript that's presenting statistics, a lot of times the stats are kind of self-explanatory and sometimes not so. And when it's more complicated, I will go ahead and diagram them here in the lecture notes so that you know what you're looking at. Where does this come from? At the end of this first sentence. With alpha set of 0.05, ANOVA reveals significant treatment effect for financial incentives. F with 2 and 18 degrees freedom is equal to, and so forth. I took that last part of the sentence and diagrammed it. Symbol for the F statistic is here. Degrees of freedom appear within parentheses here, and yes, I'll explain where you find these. The obtained value for the F statistic comes next. This MSE is abbreviation for the mean square error, which was 193.73. I'll show you where to find that. And the p-value, the obtained probability value of 0.035. All of these statistics came from the same ANOVA summary table that we looked at earlier. So I reproduce it here. And once again, I've added call-out numbers to make it easy to find things. In reporting the results, we're going to report an F statistic. And the F statistic has degrees of freedom. Those are the first real values we need to report. Degrees freedom are within parentheses, and for this analysis, degrees freedom are 2 and 18. I refer to those degrees freedom in this section. The two values within parentheses, 2 and 18, are the degrees freedom for the F test. These values appear in the Jamovi summary table below the heading DF. With the call out number 1. Okay, call out number 1. Here's the heading DF. Oh, DF is abbreviation for degrees of freedom. Degrees freedom for incentives was 2. Degrees freedom for residuals was 18. That's the order in which you place them in your write-up. Degrees freedom for incentives goes here, and the degrees freedom for residual term goes here. We have our degrees of freedom filled in. We continue. I'm on page 47 of the lecture notes. Obtained value for the F statistic. Obtained value for the F statistic is value that's used to test the omnibus statistical null hypothesis. This value appears in the Jamovi ANOVA summary table below the heading F. I've identified it with call out number 4. For this analysis, F was 4.05. Let's see, call out number 4. There's call out number 4. Yep, sure enough, the heading is F. My obtained F statistic was 4.05, and I inserted it there. Notice this is kind of a long way of presenting the F statistic. It's basically saying my F statistic is equal to 4.05, but I interrupted it by putting degrees freedom there, and that's standard for test statistics like the F statistic. Obtained F statistic, 4.05. We continue. I'm on 47. And what's this statistic? Mean square error. In the preceding excerpt, the symbol MSE represents mean square error. That's the error term for our analysis. And yes, it is good form to include the error form for your analysis anytime you're reporting results for a null hypothesis significance test. In my ANOVA summary table created by Jamovi, this statistic appears at the location where the column headed mean square intersects with the row headed residuals. There we can see the mean square error was 193.73. Now, okay, so the column headed mean square, that's call out number 5. There, column headed mean square. It's going to come from this column. But what row was that again? The row headed residuals. That's right. Residual means pretty much the same thing as error. So it makes sense that it would be to the right of the heading residuals. So mean square column, residuals row, the value is 193.73. My mean square error, 193.73, it goes in this location. We continue on page 47. The obtained probability value, the obtained p-value. In truth, this is probably the first thing that you, the researcher, are going to look at. This is probably the first thing your reader is going to look for. The obtained probability value for the F test appears at the location where the column headed P intersects with the name of your categorical predictor variable incentives. I have call out numbers here. Okay, here's the column headed P. Name of my independent variable incentives, my obtained p-value for the omnibus statistical null hypothesis. The obtained p-value is 0.035. Earlier, we talked about how that's smaller than 0.05. That's how we know we had a significant omnibus treatment effect. Where does it go in my write-up? For the end of the sentence, the obtained p-value is here. P is equal to 0.035. So I have filled in this last part of the sentence, which had been diagrammed. Let's keep going. I'm still on page 47, halfway down page 47. It's time to think about the omnibus index of effect size. Knowing that you have statistically significant results is one thing, but you also want to know how big is your treatment effect. The omnibus index effect size is the statistic that reflects overall strength of the relationship between your categorical predictor variable and the quantitative criterion variable. Skip down to my excerpt highlighted here. For this analysis, the omega squared value was 0.23, indicating that financial incentives accounted for 23% of the variance in exercise minutes. That's how I wrote it up in the summary. In the ANOVA summary table created by Jamovi, this statistic appears at the location where the column headed omega squared, remember that's the Greek letter omega with a squared symbol above it, appears at the place where the column headed omega squared intersects with the row headed with the name of your categorical predictor variable incentives. So is this true? Was omega squared really 0.23? Let's go back up to the output. Here's the column headed omega squared to the right of the name of my independent variable. Yes, omega squared was 0.23. That is my omnibus index of effect size. So I've reported results pertaining to the overall effect. I know there is a statistically significant relationship between incentives and minutes of exercise, but now we're going to dig deeper. Now we're going to look at the focused comparison significance tests and effect indices. Which specific conditions were significantly different from other specific conditions? And how big was that focused comparison treatment index of effect size? So, bottom page 47, we begin this section, focused comparison significance test and effect indices. Here's the same table presenting post-hoc comparisons that I referred to earlier. Let's see how I wrote those up in the manuscript. Below the heading mean difference, the first value is negative 3.14 because this is the value obtained by performing the subtraction. It's reported in the manuscript excerpt in the following sentence. Comparison showed that the low incentive students engaged in 3.14 fewer minutes of exercise than the medium incentive students. Where did that come from? The row headed low minus medium, and the column headed mean difference, negative 3.14. We covered those earlier. So, focused comparison significance test. The Jamovi application performed Tukey's HSD test to determine whether the difference between these two means was statistically significant. Probability value from the test appears in the column headed P Tukey, and that's my call out number 4. Yep, this is the column headed P Tukey. The first value in this P Tukey column is probability value for the comparison of the low incentive condition to the medium incentive condition. The obtained value of P Tukey is 0.907, which is larger than our selected alpha criterion of 0.05. This indicates that the difference between the two means was not statistically significant. And we reported this result in the following sentence from the manuscript excerpt. A difference that was not statistically significant according to the Tukey HSD procedure. P was 0.907. Where did that come from again? Below the heading P Tukey. For my first comparison, p-value is 0.907, non-significant. We continue. Okay, it was non-significant, but maybe it still had a big focus comparison index of effect size. Below the heading Cohen's D, the value negative 0.23 is the obtained D statistic for the comparison between the low incentive condition and medium incentive condition. The values in this section the values in the section headed 95% confidence interval tells that the confidence interval for this D statistic extends from negative 1.35 to positive 0.90. In the manuscript, these results were reported in the following sentence. According to Cohen's criteria, the corresponding D statistic represented a small effect. The D statistic was negative 0.23, 95% confidence interval extended from negative 1.35 to positive 0.90. First of all, is that what the table shows? Yes. In the column headed Cohen's D statistic, Cohen's D for the first comparison was negative 0.23, and its confidence interval extended from negative 1.35 to positive 0.90. That's our first focused comparison index of effect size. And by the way, one of the things that I want you to learn for this unit is how to report results from Tukey HSD test. Notice I inserted this D statistic for the Tukey HSD test. I inserted the D statistic at the end of a sentence, I have a comma, and then I present the D statistic and the confidence interval. Notice I did not enclose all of this within parentheses, and that's what APA style prefers. APA style prefers that when possible, avoid putting parentheses around square brackets, and when possible, avoid putting square brackets around parentheses. So you don't really need them. You just end your sentence with a comma, and then present your D statistic and the confidence interval, and you avoid making things look cluttered with all those brackets within parentheses and so forth. I am still on page 48, very bottom, page 48. Last part of the preceding sentence follows standard APA style for reporting a statistic and its confidence interval. I diagram it below. Earlier, I showed how to report an F statistic, which is a null hypothesis significance test. What about a D statistic, an index of effect size? The format preferred by APA style looks something like this. You begin with your symbol for the statistic. I'm about to report a D statistic. Then you provide the attained value for the statistic, which in this case, it was negative 0.23. I'm going to provide the confidence interval, but I have to tell the reader what my confidence interval is. I've decided to report 95% confidence intervals. And then I provide the lower limit and the upper limit of the confidence interval. They are enclosed by square brackets. Notice that's not round parentheses, it's square brackets. And notice I separate the numbers by a comma and a space. Don't have a dash separating the two numbers. You might confuse some people into thinking that this value is a negative value, which is not. Instead, separate them by a comma. I illustrate that here at the top of page 49, and then below that, I have bullet points explaining the various parts of this. So that was just one comparison. That was, what was it, the low versus medium comparison? That's only one of my comparisons. What about the others? Go back to page 49. Halfway down page 49, we have this. Results for the remaining comparisons. Thus far, the section is focused on just one of the three comparisons included in the Tukey HSD procedure. The last two sentences of the last paragraph of the manuscript excerpt reported the corresponding D statistics and confidence intervals for the other two comparisons reported in the Jamovi post-hoc test table. And these results can be interpreted in the same manner, and I do so. Below, I provide a paragraph that reports all of the D statistics for all comparisons, and it follows the same format that I used with this first comparison. That was page 49. Page 15, I give you a checklist of things to think about when you're reporting analysis variance with one between subjects factor. And we come to the end of this chapter. Hatcher stops lecturing here, and students begin working. Students begin working on Jamovi Exercise 09004, ANOVA with one between subjects factor, interpretation, and write-up. You know how to request the analysis. In this exercise, you're going to learn how to make sense of your results and how to write up those results. And what chapter is it that we have been looking at for the past 45 minutes or so? It was Lecture Notes, Chapter 090, ANOVA with one between subjects factor.